Greetings, Mr. Sutton, bringing you the IM3 Honors 4-3 Extra Practice Solutions on Quadratic Formula. For this problem, this one looks kind of nasty to even think about factoring. I'm just going to move everything over to the left and use quadratic formula on this. So we'll have 8x squared minus 4x plus 5 equals 0. I have an a value of 8, b of negative 4, c value of 5. And here's my quadratic formula. Negative b plus or minus square root of b squared minus 4ac all over 2a. Plugging all that in, we've got negative 4 for that b value out there, plus or minus square root of negative 4 squared with a little parentheses in there, minus 4 times the a value 8 times the c value 5, all over 2 times the a value of 8. Going a little bit further, we've got minus 4, so that's positive 4 out there, plus or minus square root of, that's going to be 16. And then we've got, let's see here, negative 4 times 8 times 5. You can actually multiply these in any order. So if I do 8 times 5, that's 40. 4 times that's 160, and we're subtracting that. All over 2 times 8, so over 16. 16 minus 160 is 144, negative 144. Now I can simplify this radical a bit. Since I've got a negative in there, that comes out as an I. And I happen to know that 144 is the square of 12, so this is going to be 4 plus or minus 12i when all is said and done. And we'll have 16 on the bottom still. I can reduce this a little bit here. 4, 12, and 16, all divisible by 4. So reducing each of these by 4, I can rewrite this as 1 plus or minus 3i all over 4. For this quadratic equation, I'm going to go ahead and use the quadratic formula. It may or may not be factorable, but quadratic formula always works. So let me just rewrite this so that the formula is a little easier to use. So I'll write this as 6x squared minus 1x minus 15. And then I can very easily pick out that we have an a value of 6, a b value of negative 1, and a c value of negative 15. So here's our quadratic formula. Negative b plus or minus square root of b squared minus 4ac all over 2a. Plugging things in, we've got negative 1. Notice I color-coded those. And we have the plus or minus the square root of negative 1 squared minus 4 times the a value 6 times the c value negative 15. All of that over 2 times the a value of 6. Simplifying further, negative 1 is 1. Plus or minus square root of this negative 1 squared is now a positive 1 in there. And this is going to take a little bit more work, or some cleverness maybe. We have negative 4 times 6 times negative 15. Now I could wuss out and do this on the calculator, but I'm going to try to do this mentally. You can actually multiply these in any order you want. So we could do 4 times 15, which I know is 60. 60 times 6 is 360. And the two negatives here gives us a positive. So you don't need the calculator, but you could certainly use one. So that's plus 360, all over 2 times 6, which is 12. And it almost seems like a waste, but we'll add this together right now. This is 361 inside the radical. And now we have a little bit of a conundrum. What is the square root of 361? Is that a perfect square? I don't know. For this, I am going to wuss out and use the calculator. So here's my calculator. We're going to do square root 361. Let's try that again. Square root 361. There we go. I had numlock off. I want numlock on so I can use my number pad. And that does come out to 19. Beautiful. I thought it might be a perfect square, but you don't really know sometimes until you use the calculator. So we've got two solutions. 1 plus 19 over 20, or 12 rather. That's 20 over 12. 20 over 12 reduces to, let's see, 10 over 6, so 5/3. And then we also have 1 minus 19 over 12. That's negative 18 over 12, which is negative 3/2. So it actually could have been factored, it just wouldn't have been pretty. To solve this quadratic equation, we might start by putting this thing in standard form. It looks like it's one of those that would be easy to at least consider factoring, so let's try it out. We'll subtract 1 to get that on the left side. But now, if I'm looking for numbers that multiply to -1 and add up to 4, that's just not doable. So we're going to have to go to quadratic formula at this point. Now, what we can see here is that we have an a value of 1, b value of 4, and a c value of -1 since I moved that 1 over to the left side. So that's what we'll use in our quadratic formula, -b plus or minus square root of b squared minus 4ac all over 2a. So plugging all that in, we have -4 plus or minus square root of 4 squared minus 4 times 1 times the c value of -1 all over 2 times that a value of 1. Simplifying further, we've got a -4 out there, plus or minus square root of 16, and then we have minus 4 times 1 times -1. That's a grand total of plus 4 inside there. So careful with those signs. And we have 2 in the denominator. So that's 16 plus 4, which is 20 inside there. And we can simplify this a little bit further. 20 can be simplified. I can split that up into radical 4 times radical 5, 4 being a perfect square. Square root of 4 is 2, so we have 2 radical 5 there. And since 4, rather -4, 2, and 2 are all divisible by the same number, I can reduce all 3 of those things at the same time by 2. So this will then end up being -2 plus or minus just 1 radical 5 all over 1, or you could just call this -2 plus or minus radical 5. Either way. On this multiple choice question, what they've done is basically take a long problem and make it a little bit longer. So we're talking about some solutions to 2x squared minus 8x minus 5 equals 0. P and Q, and they're saying P is the larger of the two solutions. We want to know what we get when we do P minus Q. So just thinking ahead, we have to figure out the solutions to this equation and then basically subtract them, bigger minus smaller. I could try factoring this, but I'm not going to. I'm just going to go straight to quadratic formula on this one. So here it is, -b plus or minus square root of b squared minus 4ac all over 2a. We have an a value of 2, a b value of -8, a c value of -5. So plugging all this in, we have -8 for that b value there, plus or minus square root of the b value -8 squared, minus 4 times the a value 2 times the c value -5, all over 2 times the a value 2. Simplifying further, -8 is +8, plus or minus square root of, now we've got 64 in there, and then -4 times 2 is -8, -8 times 5, -5 is +40, and then we have 2 down below. So that is, let's see here, 64 plus 40 is 104, square root of 104. So you actually could do this problem without doing any more simplifying, but we'll simplify it a little bit more just for a little bit of practice here. So 104, the biggest perfect square that goes into that, I believe, is 4. 4 times 26. And then square root of 4 is 2. So we have 8 plus or minus 2 radical 26 all over 4. Now, at this point, well, I guess I could simplify just a little bit more. Why not? 8, 2, and 4, all divisible by 2. So this is 4 plus or minus 1 radical 26 over 2. Okay, there we go. So at this point, we need to do P minus Q. P and Q are these two answers right here. The P is the larger of the two. It's going to be 4 plus radical 26 over 2. Q is the smaller one. That's going to be 4 minus radical 26 over 2. And we're subtracting that. Now, how do I know which one's bigger and which one's smaller? Well, these are identical expressions, except that with one of them I'm adding a positive number. With the other, I'm subtracting that same positive number. So definitely the one where we're adding the number is going to have to be bigger than the one where we're subtracting the positive number. Anywho, we can reduce these a little bit, combine them a bit. So we have the same denominator. We can just subtract the numerators. 4 minus 4 is going to be 0, so those cancel. And then radical 26 minus negative radical 26. That's actually radical 26 plus radical 26. That gives me positive 2 radical 26 in the numerator. Still have that denominator of 2. This 2 and this 2 can cancel, leaving us with radical 26, which is answer choice A.